Hi everyone. In this given problem statement, we have to generate parentheses. Given n pairs of parentheses, write a function to generate all the combination of well-formed parentheses or well-balanced parentheses. What do I mean? Let us take the example of n equal to 2, right? It is said that it is going to be n pairs. So when you have pairs, right, it would mean 2 into 2 equal to 4. So what is the possible number of combinations? So first let us understand, what are the valid one. So there are two type of brackets that can form. One is that open bracket, another is the closing bracket. Okay. So if I add a closing bracket before and then I add a opening bracket, right, it's not a valid bracket or a well-formed parenthesis, right? So we are going to keep a track of number of closed and open brackets. So number of closed is going to be 0 initially and open is going to be 0. So whenever, right, you're going to given a function to write all the combination, right, you can understand this can only be solved using backtracking, or backtracking could be a method of doing it. So here, right, few things like to understand, right? If my open is less than the closed, then I cannot have more closed brackets. So let's say if the open is 0, right, can I increment closed by 1? No, I cannot. Okay, so because if I do it, right, it would form an invalid parenthesis group. Okay, so I will always have to maintain it. So let's say open is 1, closed is 0. I can add a close? Yes, I can. Or let's say open is 2, right? Can I add closed? Yes, and then I have to again close it. So in this way, it is going to work. Let us take an example. Let's say when n is 3, right? N is 3. So let me draw the tree diagram. So I will have two options, right? Can I add an opening bracket or can I add a closing bracket? So let us say, right, initially only option available for me, because both open and closed are going to be 0. So I can add only one opening bracket. Once I have done that, right, then there are two options. Can I add a closing bracket and can I add a opening bracket? Yes, I can add a opening bracket. So I will add that. And can I add a closing bracket? Yes, I can add that closing bracket. Now from here, right, can I add a opening bracket? Yes, I can. So I will say add a opening bracket out here. And can I add a closing bracket? Because, right, the open value is greater than the closed value, so I can add it. So the value would be 2 opening bracket and 1 closed bracket. Similarly, out here, right, can I add a closing bracket out here? No, I can't. Can I add an opening bracket? Yes, I can. So only possibility out here, right, would be adding one opening bracket. Once that is done, right, now can I add, in this case, right, can I add another opening bracket? No, I cannot, because here would be a base condition. So if my open is equal to n, right, then I cannot add any more opening bracket. So I cannot do it, but yes, I can add a closing bracket. So here, right, the value would be closing. Similarly, right, out here, can I add a opening bracket? Yes, I can. So the value would be 2 bracket closed, another opening bracket. Can I add a closing bracket? No, I cannot, because it's not possible. Because if I add the closing bracket, right, number of closed bracket will be more than the open brackets. Out here, right, can I add another opening bracket? Yes, I can. So the current value would be both and another opening bracket. Can I add a closing bracket? Yes, I can, because the conditions that we set, right, it's not failing, so I can do it. Now out here, right, the only possibility for me, right, to add is a closing bracket out here. Then again, only possibility is to add a opening bracket, and I cannot add a closing bracket out here. So it would be another opening bracket. Now here, can I add a opening bracket? No, because the number of open brackets, right, would exceed. So for me, the only possibility is to add a closing bracket. So the value would be one close bracket. And here, right, I cannot add a closing bracket because if I add a closing bracket, the number would increase. So I can add a opening bracket out here. So here, right, as I am already telling, right, the only possibility, because you have reached the number. So this would be the value. Here, only possibility, because I have exceeded the number of opening brackets, so only possibility would be this one. Here, the can I add a closing bracket? Yes, I can. So bracket close, and out here the other one would be one closing one. So I think we have reached all of them. Yeah, just forgot to add one more possibility, right? And this would be, right, here, or let's say out here, right, I could had, instead of adding a closing bracket, right, I could basically add one more opening bracket out here. So the value would be opening bracket. Then from here, another one could be close, a close one. And if I come back, so the other one is going to be this. So here, right, if you can easily understood, right, the time complexity of it is going to be on a huge scale. I think it would be uh, kind of in a factorial range, right, because there are so many possibilities out here. So I'm going to give you the time complexity of it, but this is going to be the decision tree of this entire one. And it's very important for you to, right, to understand or to create or draw the decision tree. Once you are able to understand or sketch the decision tree, right, the most of the solution is going to get solved, so you can easily come up with a solution. So let us jump to the Python solution, and then let us discuss the time complexity of the given problem. So the first thing that we need to do, right, we need to create our result where we are going to store our brackets. Then what we are going to do, right, we are going to create our function def backtracking, and here I'm going to pass in my open and closed brackets. So open and closed, and let me pass in the value. So backtracking, initially the value of open and closed are going to be 0. So here, right, what would be my base condition? So if n equal to closed, which is equal to open, right, if the value of closed and open are same, right, so in that case, right, we are going to add this value to result. Also, one more thing I forgot to add, which is the current stack value. So it would be stack, and stack is going to be empty. And I also need to pass in the current stack. So stack, and here let me give the value stack. Now if it is the result, right, so we need to merge, or if you look into the result, right, so stack is in form of a list, right, we need to form it into a string. So in order to do it, so I can say res dot append, and I can say I have to join that value, so dot join stack dot copy, just to ensure, right, whenever we are adding this type of values, right, because it's a pass by reference, right, we need to always store a copy. If I don't store a copy, the value is going to change. So that's a very important thing to remember. And I can return. Now my condition, if open is less than n, in that case what I can do, I can add to my current stack. So stack dot append, and I can add an opening bracket. Then I can call the backtracking function backtracking, and here I will say open plus 1, and then I will say close, or let's say closed in this case, and I will pass in the stack, and I will say stack dot pop after it. And if open is greater than closed, so in that case I can add a closing bracket. So stack dot append, add a closing bracket, say backtracking, I will pass in open closed plus 1 and pass in the stack, and I will say stack dot pop at the end. And at last I have to return the result. So return the result. Let me run the code. I hope if everything is fine, it should run properly. As you could see, the public test case is passed. Let me submit the code, and all the other test cases also passed. So if I look into the time complexity of it, right, the time complexity would be in the range of 2 to the power n, which would be a exponential kind of a optimization. So here, right, because it's a backtracking problem, so you can expect those type of results. So that is pretty expected. So that's all for this video. See you in the next one.